All right, it is day 13, which means it is time for a brand new topic. We have done a lot of work with slope-intercept form equations that were presented to us in slope-intercept form over the last couple of weeks. We've written equations from a graph, from tables, from word problems, and now we're going to be continuing working with equations, except they're going to be presented to us in a different form. So we're going to be talking about standard form and how to convert standard form to slope-intercept form so that it's more useful to us, because we now know how to graph a line using its y-intercept as our starting point and then following the slope. So again, since it's a new topic today, I've provided you with a notes template. Again, if you have a printer, hit pause, print this out so you have it. If you don't have access to a printer, you can easily write these down as I fill them in with you. So before we go and fill in our notes, here's a very quick real world example. So we know that we have two different ways that we've talked about in class to measure temperature. And I know in science you've used both Celsius and Fahrenheit. So we are going to talk about, if we were given the degrees in Celsius, how to convert it to Fahrenheit. But this isn't the only way we can look at this equation. We can also be given the degrees in Fahrenheit, which we could substitute into this and solve. But it would be much easier if we wrote it in terms of C. So we can actually move things around and work with equations just like we did when we were solving, as long as we follow the same rules that apply, right? The property of equality, what you do to one side, you have to do to the other. To actually move things, right, we can't just erase it. We have to use inverse operations. So if F is equal to 1.8C plus 32, but my goal was to write this equation in terms of C, in other words, I want to isolate C, then I have to get rid of everything that's on the same side of this equation as C. And we're going to use the same process as if we were solving equations. So since C is our variable and it's attached to 1.8, that would be our coefficient. The first thing we move would be this 32. If that's plus 32, we're going to be subtracting 32 on both sides, but then something different happens here. Usually you end up with two numbers and I could subtract them. However, F and minus 32, they're not like terms. So I have to leave that as an expression that says F minus 32. These cancel out because they're inverse operations, and I'm going to bring down my leftovers. Equals 1.8C. So slowly we're getting C more isolated, except we have one more thing, that 1.8, and even though that's a decimal, I know I don't want to stress you out, it's the same thing as multiplication. So the inverse of multiplying would be dividing both sides of my equation by 1.8. Except when I say both sides, there's actually two terms over here. So every single term in this equation has to be divided by 1.8 to keep it balanced. So my 1.8s cancel out on my right side, since those are inverse operations, and I'm actually going to leave this as a fraction. So we're going to leave it as F divided by 1.8 minus 32 divided by 1.8. So we can leave it just like that for now. I know we don't have our calculators like we would, but what we're going to do now is that same idea, except I'm going to be giving you equations written in standard form, and we're going to convert them to slope-intercept form so that they're more user-friendly for us. All right, if you have not done so and you have access to a printer, print out this sheet. We're going to be filling in our notes right now. If you don't have access to a printer, totally fine. You can write this on a separate sheet of paper. So again, these notes are on converting equations into slope-intercept form, and we are specifically going to be looking at equations presented to you in standard form. So that is when your x and your y variables are actually on the same side to start. So we know that slope-intercept form is y is equal to mx plus b, where m stands for the slope and b stands for the y-intercept. So this is nothing new. This is what we've been talking about for the last couple of weeks. So if the y term is not alone, meaning on this side alone, we must convert the equation into slope-intercept form before we can graph it, because we know how to graph equations starting at the y-intercept and following the slope. But this equation has to be given to you in slope-intercept form, or we have to convert it. So here are the steps, and we'll go through the steps first, and then we'll look at converting two equations together. So you are going to first find the y variable, and that's what we're going to be getting isolated. So when I say find, decide if it's on the left side or the right side of your equation. Starting on the same side as the y variable, you're going to perform inverse operations on the x term on both sides of the equal sign. And what that really means is you're trying to move the whole x term from one side of your equation to the other. We're going to use either addition or subtraction depending on the sign of that term. We'll talk about what that looks like in the example in a second. Once you have done that and you've completed inverse operations on both sides, you're going to then perform inverse operations on the y term on both sides of the equal sign. And what that means is you're getting rid of the coefficient, that number right next to that y. That means you're either going to have to multiply or divide, but in this case it's going to be every term by the coefficient of y. So if you have two other terms, then you should have three distinct fraction looking things. We'll talk about that. Then you're going to simplify if possible. Remember, you're a mathematician. You should always be completing your division or at least simplifying any fractions. And then you're going to rewrite the equation as y equals mx plus b. If you can't figure out what the slope is or the y-intercept is from the equation that you've just converted, then you probably made a mistake. So we're going to go through two examples, and then we're going to use the inverse operations using the notes that we have already looked at. So I'm going to move this up here. So again, I can see the notes. I'm going to be filling in right under these two examples. If you didn't print this, that's okay. Just make sure you are writing down these examples so that you have them when you work on your practice. So I'm going to use this to separate my two sides. We talked about this in class. If you're comfortable not actually drawing the vertical line, that's fine. But for me, I'm going to use it to organize my work. So I'm going to find the y variable. That is located right here. So I have found y, and I notice that it has a negative 4x and a 5 on the same side as y. Our goal is to get y alone, so we have a lot of work to do here. Step 2. Starting on the same side as your y variable, perform inverse operations on the x term. So here's the x term, negative 4x. And that means I need to move the whole x term from one side to the other by either adding or subtracting. Don't forget, inverse means the opposite. If this is a negative 4x, to undo that, I have to use adding 4. So negative 4x plus 4 will give me 0, but what I do to one side, I have to do to the other. And notice where I'm putting it. I'm not lining it right under the 40 because 40 and 4x are not like terms. So I cannot actually add 40 plus 4x together. I have to leave that as 40, let's use a different color. I have to use that as 40 plus 4x. I cannot combine those. Same rules apply though. I'm going to bring down my leftovers. The thing I haven't used over here was 5y. So my step 2 asked me to remove or perform inverse operations to get negative 4x from one side to the other, and we have. The third step is to perform inverse operations on the y term. So again, we're getting closer to getting y isolated, but it still has y attached using multiplication. The inverse of multiplication would be division, and every single term has to get divided by 5 here. So I'm going to draw 3 different division signs, and I'm going to divide each of these terms by 5. 5 divided by 5 is 1, so that's going to leave me with the y that I'd like. There's our y. 40 divided by 5 can be simplified. 40 divided by 5, this is what we're doing, is 8. And 4 divided by 5, that cannot be simplified, so we can leave that as a fraction, 4 over 5x. My one last step, This is almost looking like mx plus b, but we could see the b came first and the mx came second. So we can move that around because it's staying on the same side to say 4 fifths x plus 8. And from here, I should be able to figure out what my slope is and what my y-intercept is. I could see my slope is 4 over 5 because it's next to my x variable. And my y-intercept is 8 because that's the term that does not have a variable next to it, and my y is isolated. So this equation that started out looking like negative 4x plus 5y equals 40 is the exact same equation as y equals 4 fifths x plus 8. We're going to do the same thing to our second example. This one looks a little bit different because there's no number in front of x. But don't forget that coefficient that we don't see is just a 1. So I'm going to add that 1 in there for me. Same steps. Here's where y is. Y is what I need to isolate, but the first term I have to move is my x term by using adding or subtracting. Since this is a positive 1x, the inverse of adding, or the inverse of a positive 1, would be a negative 1. So I'm going to subtract 1x here, and notice where I put it. I do not put it right under my 8 because they're not like terms. We'll complete this work. 1x minus 1x is 0, or that's now canceled out. 8 minus 1x has to stay 8 minus 1x because they're not like terms. And the term on the left side that I have not used yet is not 2y, it's negative 2y. So now I brought down my leftovers. I have negative 2y equals 8 minus 1x. And my next step is to perform inverse operations on the y term. So whatever the coefficient of y is, which in this case is negative 2, I need to divide every single term that I see here by negative 2. So I'm really making 3 different fractions. And now I'm going to go through and simplify. Negative 2 divided by negative 2 is 1y, which leaves me with the y that I'm looking for. Y is now isolated on the left side. 8 divided by negative 2 is negative 4. And be careful here, negative 1 divided by negative 2 is positive, but 1 divided by 2, or 1/2, cannot be simplified. So we're going to leave that as 1/2 x. So without moving this around, rewriting it, I can already tell that my slope is 1 over 2 because it's next to x, and my y-intercept is negative 4. But to make it look like mx plus b, I can convert that to say y is equal to 1/2 x. Be careful, keep this sign with it, minus 4. My slope is still 1/2. My y-intercept is still negative 4. So we have just converted 2 examples together. You're going to notice on your notes you have 2 other examples that are done for you. So they're fully converted step by step so you can follow along. If you guys have any questions, please send me an email. You have a worksheet to complete today, and then on depending on if you're A day or B day, on Wednesday and Thursday you'll have a quizzes to practice. So you're going to be converting from standard form to slope intercept form. That way you guys are set up to graph.